Okay, get ready, because we're about to mess with one of the biggest ideas you probably have, the very nature of time itself. Seriously, forget everything you've ever heard about time flowing like a river. We're going to look at this in a completely new light, and it's built on an idea that's way simpler and a lot more powerful.
And this is it. This is the whole idea in a nutshell. Time isn't some invisible thing we're all just floating through. It's a measurement. It's a scorecard we keep by counting things that happen over and over again, the drum beats of the universe. You see, without that beat, there's nothing to count. And without the count, well, there is no time. So on one side, you've got the classic metaphor, time is a river, just carrying us along. And it feels right, it feels intuitive, but it's actually pretty misleading. On the other side is our new model, time as a simple count of change. Think of it like a ruler. A ruler's only useful because its markings are regular, right? Well, time is the exact same deal. We're just using regular, repeating changes, like sunrises or the swing of a pendulum, as our markings. Okay, so if time is just a count, how do we actually do the counting? Well, it turns out that every single clock, and I mean everything from an ancient sundial to a super advanced atomic clock, is built from the same three basic ingredients. So let's pull back the curtain and look at this secret recipe. Here it is, the universal blueprint for keeping time: a repeater, a counter, and a rule. It's a really simple trio, but it's incredibly profound. And once you see this pattern, I promise you're going to start spotting clocks absolutely everywhere. Let's break down what each part does. First up, you need a repeater. This is the physical drumbeat. It can be literally anything in the universe that repeats in a stable, predictable way. A pendulum swinging back and forth, a tiny crystal vibrating millions of times a second, a planet orbiting the sun. That's your beat. The universe provides this part for free. Next, you need a counter. This is the part that does the actual bookkeeping. It's the mechanism that just tallies up the beats from the repeater. How many swings have happened? How many vibrations? Without a counter, the rhythm is it's just a rhythm. It's not a record of time yet. And finally, we have the rule. Now, this is the human part. This is where we come in. We all get together and decide that, say, this many beats equals 1 second, or that many sunrises equals 1 day. It's a convention, a social contract that lets all our different scorecards speak the same language. Take away any one of these three pieces, and the whole idea of a shared time just completely falls apart. And what's so cool is that the entire history of making better clocks is just the story of us finding better and better repeaters. And today, the absolute gold standard, well, it's the cesium-133 atom. We literally count a specific number of its quantum flips, these incredibly regular energy transitions, and by our agreed-upon rule, we call that 1 second. This unbelievably steady atomic drumbeat is what synchronizes our entire global civilization. But here's the thing, we didn't invent this system of repeater-counter rule. We just learned how to listen. Nature is absolutely full of these repeating patterns, these hidden metronomes just ticking away. Once you know the recipe, you start to see that we're surrounded by potential clocks. I mean, just think about it. Your own body has a circadian rhythm. That's a clock. The oceans have tides that are driven by the moon. Another clock. We have the seasonal cycles every year. The sun itself has this 11-year cycle of solar activity. And way out in deep space, you have pulsars, these dead stars spinning like cosmic lighthouses with breathtaking precision. Every single one of them is a natural repeater, a beat we could build a clock around. And this timeline just lays it out so perfectly. The history of timekeeping isn't some grand discovery of time. No, it's a history of engineering. It's just the story of us finding and adopting better and better repeaters. We went from the sun's shadow, to a swinging pendulum, to a vibrating quartz crystal, and now to a flipping atom. The repeater got better, so our scorecard just got way more precise. Of course, there's a catch. There's always a catch, right? In the real, messy world, no repeater is absolutely perfect. Everything wobbles a little bit. The Earth's rotation is actually slowing down. Crystals get affected by temperature. Even our amazing atomic clocks are influenced by gravity. Our perfect, neat systems always have to deal with messy reality. So what do? We get clever. We engineer compromises. This table shows it perfectly. Take the Earth's spin, our original repeater. It's slowing down because of things like tidal friction from the moon. The fix? Every so often, we add a leap second to our super precise atomic clocks. It's basically an accounting correction, right? It's us telling our atomic scorecard, hey, hold on a sec, let the slightly wobbly sky catch up. Now, this brings up a really fascinating paradox. We live in a universe that's governed by entropy, which is just a fancy way of saying that things tend to get more disordered and messy over time. So, if everything is supposed to be running down, how in the world can we have these orderly, repeating cycles? Let's put it in simpler terms. You spill your coffee, right? We all know it's not going to magically reassemble itself and leap back into the cup. That one-way street is the arrow of time in action. So, how is it possible that the sun reliably rises again and again and again? How can cycles even exist in a world that seems to only move in one direction? Well, the solution is to see them as two totally different kinds of patterns. The arrow is the universe's overall statistical trend towards messiness, but cycles are like little local eddies in that big river. They can create these temporary pockets of order. Think of a hurricane spinning itself into a beautiful, coherent shape by burning through energy and basically making a bigger mess somewhere else. And here's a fantastic way to picture this. Imagine a spiral slide at a playground. Gravity is always pulling you in one direction. Down. Non-negotiable. That's the arrow of entropy. But the shape of the slide forces you into these loops on your way down. That's the cycle. So you see, the universe can have both a one-way trend and repeating patterns at the exact same time. And all of this leads us to our final, and maybe the most profound idea of all. It completely changes how we should think about stability. If everything is constant change, if everything is flow, what does it even mean for something to stay the same?
Just look at these examples. A whirlpool in a river, a candle flame, a human body. They all maintain a stable, recognizable shape, don't they? But they are not static at all. They are patterns of pure flow. Water, wax, oxygen, food, it's all constantly moving through them. Their stability isn't about being still, it's the signature of a process that's constantly and successfully renewing itself. And here's the mind blower. This applies directly to you. The stability that you call you is an active process. Your heartbeat, your breath, the constant turnover of your cells, these are your maintenance cycles. They're the repeating drumbeats that preserve the pattern of you, even as the actual atoms that make you up are constantly being replaced. And that leaves us with this incredible final thought. Stability, whether you're talking about a clock or a star or a person, is not the absence of change. It's a dynamic, ongoing performance. It's a pattern of renewal, a dance step repeated so perfectly, so consistently, that from a distance, it almost looks like it's standing perfectly still.